I've had a few requests to go over pH a little bit more, so I'm going to do some practice problems with you just to show you how I would do these, and hopefully it'll help you out with the assignment if you have more questions. So first things first here, we're going to look at the few questions. It says, what is the pH of a 0.0235 molar HCl solution? First thing we need to realize is, to find pH, we've been doing the negative log of the H plus concentration, right? And it doesn't say H plus concentration anywhere on here, but what we can see is HCl. So HCl is a strong acid. You see that because of the H in front there. And so that means this concentration right there is the H plus concentration. That is the H plus concentration, that 0.0235. So what we're going to do is we're going to take this. We're going to do the negative log, just like we from our chart, of 0.0235. And then we'll punch that in our calculator. Now, when I punch that in a calculator, depending on what type of calculator you have, you may have to put the number first and then log, and then make it negative, or hit negative log on your calculator and then push the number in. You'll have to experiment with that and see which one works. But when we punch it into our calculator, it should give us a number that is equal to 1.628. So that means the pH of that is 1.628. So we did that just by doing the negative log of the concentration, which was right there. Now the next one says, what is the pOH of a 0.0235 molar HCl solution? This one's a little trickier. pOH is the negative log of the OH minus concentration, but we don't have the OH minus concentration. What we can do, though, is we can find the pH and then do the opposite of it. So we'll just do the negative log as well of the H plus concentration right here. So do the negative log of the H plus concentration, so negative log of 0.0235, which we already know what it is because it's the same as before, right? And so that would be 1.628. So what we're going to do is to switch from pH to pOH. We're going to go back, just get rid of those because we already know what that is. To switch from pH to pOH, we're going to do 14 minus 1.628. which will give us 12.372. So in this case, we had to do the 14 minus because we did not have the OH minus concentration. We just had the H plus concentration. And so we solve for the pH just like normal using the H plus concentration. And then to convert it to pOH, anytime we want to convert from pH to pOH, we just do 14 minus whatever the pH is. And that's also from the chart I showed you in the previous one. I'm actually going to upload a file that'll have all those different formulas on it. That might help you with the assignment. The third one here says, what is the pH of a 6.5 times 10 to the negative third molar KOH solution? This is a little tricky. Because this is a base, we can't just do the negative log of it to get the pH. What we do with a base, if you take the negative log of a base, which is going to be 6.5 times 10 to the negative 3, negative log of the base gives us the pOH. So we'll first solve for the pOH. And that gives us a pOH of 2.187. 2.187 is the pOH, but pOH isn't what it asks for. It asks for pH. So once again, we'll look at our chart and we'll say, okay, to convert from pAOH to pH, we're just going to do 14 minus 2.187. That's our pOH to pH conversion, and that'll give us a pH of 11.81. So you can see right there, we had to, if it's a base, you're going to have to do the negative log and then convert it to pH if you're looking for pH. If it's an acid and you're looking for pOH, you have to do the negative log and convert it to pOH. Remember, the negative log of acids gives us the pH. The negative log of bases gives us the pOH. And if it's asking for the other thing, we'll have to just do 14 minus to convert it to from pH to pOH or from pOH to pH. Here are a couple more questions. It says, what is the pH of a 6.2 times 10 to the negative 5 molar NaOH solution? So this is a base once again, so we're going to do the negative log of this base, right, of 6.2 times 10 to the negative 5. We do the negative log, and that's going to give us the pOH, which gives us a pOH of 4.2. Now, we don't want pOH, we want pH, and so what we're going to do is 14 minus that to make it into pH, so 14 minus 4.2, and that is going to be equal to 9.8, if I did my math right. So our pH is 9.8. The reason why we did it that way is because at the base we had to do the negative log, which gave us the pOH, and we had to convert that to pH. Number 6 says a solution with an H plus concentration of 1 times 10 to the negative 7 is said to be neutral. Why? Well, if you do the negative log of 1 times 10 to the 7th, or 1 times 10 to the negative 7, it gives us a pH of 7. It would also give us a pOH of 7, and then we could find the OH minus concentration would also be 1 times 10 to the negative 7, so there'd be the same amount of OH minuses as there is H pluses. So in the end, it'd be all neutral. There wouldn't be an abundance of H pluses, there wouldn't be an abundance of OH minuses. They'd be completely neutral. That would not be acidic or basic. Now, a lot of these questions on the homework you have are easier than these ones. You don't even have to do conversions, where you'll just do the negative log of the acid or the negative log of the base to get the pOH. But look specifically what it is and what it's asking for, and then reference the file I'm going to upload. It's going to be a pH cheat sheet. I'll upload that and put it on right now.